So now that we understand the history of atomic structure, let's take a look at just simply the structure of atoms for the time being. So basically, we want to understand that there are three subatomic particles that we're going to be interested in. Subatomic means smaller than the atom. We have protons, we have neutrons, and we have electrons. Now, the proton we know was discovered by Goldstein. It has a positive charge, and it has a mass of 1 atomic mass unit. An atomic mass unit is defined as 1/12 the mass of a carbon-12 atom. That'll make a little more sense once we understand isotopes. But for now, just understand that these things are very small. We could measure them in grams, but it would be such a small number that it would be very difficult to work with. So a new unit was created called the atomic mass unit. And 1 AMU is essentially the mass of a proton or a neutron. Neutrons, same mass as protons, but the difference would be in their charge. A neutron has no charge. Electrons, the third subatomic particle, are very, very small. Their mass is 1/1837th of an AMU. In other words, it takes almost 2,000 electrons just to equal the mass of one proton or neutron. So when we talk about the mass of an atom, we're really talking about the mass of the nucleus. The protons and neutrons are in the nucleus, and they make up almost the entire mass of an atom. The mass of the electrons, even if there are 100 electrons in an atom, that mass is so small that it's negligible. We don't even care about it. It's simply the mass of the protons and the neutrons that give an atom its mass. And remember that all of the mass, almost all of the mass of the atom is in the nucleus, and the nucleus is this tiny, tiny little thing in the center. It's interesting to note that the neutron, because it has no charge, it took a while before they could figure out what it was. And it took a guy by the name of James Chadwick to look at some masses of atoms and realize that the mass of the atom didn't jive with the number of protons in the atom's nucleus. And so he figured there must have been something else contributing to the mass, but had no charge. And so he called it a neutron for neutral. And that's where that comes from. Electrons, of course, are negatively charged, and they're found in clouds around the nucleus. And we're going to look at electron structure much more carefully later on. Right now, we're just going to consider the structure of the nucleus for a little while. When we're talking about the basic idea of how these particles are arranged, we want to become familiar with the concept of atomic number. We already know that Henry Moseley arranged the periodic table by atomic number, and atomic number represents the number of protons in one atom of that element. Every element has a different number of protons, and so the identity of an element is determined by the number of protons. If you change the number of protons in an atom, you change that element into something else. It's no longer that element, it's a different element. The number of electrons and the number of neutrons don't have to be the same, though. For example, if an atom is neutral, in other words, if the atom itself has no charge, then that means that the number of protons, positive charges, is equal to the number of electrons, negative charges. If those two are equal, they cancel each other out, and the atom will be neutral. It is possible to not have those two be equal. That's something called an ion, and we'll see that in a little bit. The number of neutrons is also variable. It does not have to equal the number of protons, although for smaller atoms, atoms with atomic numbers perhaps below 80 or so, you will often find versions of those elements where the number of protons and neutrons are equal, but they don't have to be. And the number of neutrons can be very variable within an atom, and those are called isotopes, and we'll see those later. So we'll do just some quick practice to make sure that you understand the relationships. We're not going to focus on neutrons just now, but just on the proton and electron ratios. Remember, they should be equal if the atom is neutral. So here are some atoms: carbon, sodium, argon, and iron. And I want you to find your periodic table. Go online and find one, or quickly look in a book somewhere. And I want you to determine the number of protons and electrons that each of these elements have. Okay, stop the video and go figure out how many protons does carbon have, and therefore how many electrons does it have if it's neutral. Stop the video and come back when you're done. Are you ready? All right, well, let's see how you did. For the number of protons, you should have 6 protons for carbon. Sodium should have 11. Argon should have 18, and iron should have 26. What about the number of electrons? Well, if you remember that the number of electrons and protons are the same in a neutral atom, then we should also have 6 for carbon, 11 for sodium, 18 for argon, and 26 for iron. Now, the number of neutrons, that'll vary a little bit, and we'll talk about isotopes in a future video. But for now, that's the basics of atomic structure.